Hi, welcome to clickmyproject.com. The title of our project is Handling Selfish in Replica Allocation over a Mobile Ad Hoc Network. In mobile ad hoc network, the mobility and the resource constraints of the mobile node may lead to network partition or performance degradation. Several data replication techniques has been proposed to minimize performance degradation. Most of them assume that all mobile nodes collaborate fully in terms of sharing their memory space. In reality, however, some nodes may selfishly decide only to cooperate partially or not at all with other nodes. These selfish nodes could not be reduced the overall data accessibility in the network. In this paper, we examine the impact of selfish node in a mobile ad hoc network from the perspective of replica allocation. We term this selfish replica allocation. In particular, we develop a selfish node detection algorithm that consider partition selfishing and novel replica allocation technique to properly cope with selfish replica allocation. The conduction simulation demonstrates the purpose approach outperform traditional cooperative replica allocation technique in terms of data accessibility, communication cost, and average query delay. The disadvantage of the existing system is there is only limited memory space and many of the nodes hold the same replica locally. Then some data would be replaced and missing. A node may act selfishly using its limitation resources only for its own benefits. Since each node in a manner has resource constraints such as battery and storage limitation. Selfish replica allocation refers to a node non-cooperative action such that the node refuses to cooperate fully in selfish its memory space with other nodes. The advantage of the proposed system is each node makes its own topological graph and builds its own SCF tree by executing selfish node. Based on SCF tree, each node allocates replica in a fully distributed manner. A selfish node may not share its own memory space to store replica for the benefits of other node. Each node maintains its memory space and based on receiving requests for replica allocation. We propose a novel tree that represents relationship among node in a manner for replica allocation term the SCF tree. The key strength of the SCF tree based replica allocation technique is that it can minimize the communication cost while achieving high data accessibility. Now let's see the data flow diagram of our project. First, we have to detect the selfish node. The selfish node is detected by using the built-in SCF tree. Then the replica is allocated. If the selfish node is identified, then the replica node will be allocated. Then SCF tree based replica allocation with the degree of selfishness done. It is divided into selfish node and partially selfish node. Then by combining this both, the performance evaluation is done. In the performance evaluation, we will calculate the overall selfish node, communication cost, average query delay, and data accessibility. Now let's see the demo of our project. As we are sending the node from each node to another, we have to run 4 applications. That is, we need one client and several servers. So in our project we have to run the 4 applications. Now first I'm going to run all the applications. So this helps us to execute. We have to give the IP address of our system, that is the destination node. The IP address of the destination node is 192.168.0.68, and we have to select the file that which we want to send to the destination path. So click the send button. The file has transferred. The destination node has been detected as a replica node, so it's automatically create the replica node. So the destination node is this, it has detected as a selfish node has detected, so automatically this replica node will be run. So now we have to click this replica node button. Before that, we have to close this selfish node because in our system we can run only one server at a time. So we have to start this and run the file. When you watch carefully, when I click OK button, we can view the message that data has received successfully. So click OK button. Now the data will be transmitted from this replica node to the destination node. You can see the message that data has been received. So the main goal of our project is to build the SCF tree. We can do the node performance analysis, and we have to build the SCF tree. So now let's see how the node performance analysis works. For that, click the node performance. This is the performance analysis of a project. Here, whatever the processor that we are using at the network bitrate level, the processor, the CPU usage, the memory, the disk usage are calculated here. We can now build the SCF tree. By building this SCF tree, the selfish node is detected. So after detecting the selfish node will be ominate from a tree. So the tree has been built successfully. The purpose of our project has over. Thank you for watching.